Express the product of the binomials below as a trinomial in terms of x. So whenever it's product, it's multiplication, and we know the rules. We're going to multiply the numbers, and for powers of the same base, we're going to keep the base and add the exponents. Okay. So the only thing is, if we try to look at this as a distributive property problem, we're going to have to extend it a little bit. We have the 2x plus 5 and the x minus 3. Now, it's not quite what we had before, a single term outside distributing to a double term. So we're going to have to be a little careful that, first of all, this 2x gets distributed to both parts of the second binomial, but then also the second half, the plus 5, has to get distributed to both the x and the negative 3. Okay, each one of these arrows represents a multiplication problem. We'll do them one at a time. So the first thing we're doing is 2x times x. So we're supposed to multiply the numbers. I don't see a number in front of x, so I understand it's a 1. 2 times 1 is 2. Next, powers of the same base, the x's, we're supposed to keep the base and add the exponents. Again, where there is no exponent, it's an understood 1. 1 and 1 makes an exponent of 2. Okay, second multiplication, 2x times minus 3. Okay, multiplying the numbers, 2 times negative 3 is negative 6. There is no other x, so we just bring it with us. Okay, next, positive 5 times x. There are no numbers to multiply. There are no powers of the same base. So we just put it together and get 5x. Okay, and then last, positive 5 times negative 3. Just multiplying numbers, we get negative 15. Okay. You might have done this in a process called FOIL. First, outer, inner, last. Right? 2x and 1x are the first of each parentheses. They give you the 2x squared. The outer terms, 2x and negative 3, give you the negative 6x. The two inner terms, the 5 and the x, give us 5x. And the last one in each parentheses, 5 times negative 3, is negative 15. Doesn't matter if you want to think of it as using FOIL or whether you want to think of it as using distributive property. Either way, you're getting all 4 terms to multiply with each other. Okay, when we're done, you should see, going back to the concept of your grocery list, you should see that we have like terms. Negative 6x and positive 5x are both x terms, right? We could combine them together, make it a simpler expression to read. Negative 6 plus 5 is negative 1, and the term, the x, doesn't change when we are adding, right? Up here we were getting a product, we were multiplying, and we were done with our multiplication. Now, when we just want to put like terms together, that is called combining. And so the rules go back to rules for addition. Okay, this term doesn't combine with anything. We have no like terms for that. And this term, the negative 15, doesn't combine with anything. And that's how we end this with a trinomial, something that has 3 parts to the expression. Okay, now there's another method that we can use to multiply 2 binomials. You could think of the other method just as FOIL, but there's something else that might be useful if we take these 2 binomials. Okay, another way that we could make sure that every part of each binomial gets multiplied by each other is creating a little box where in each case we want to fill in the product of each part. So for example, we have 2x plus 5. We're going to split it up over here as 2x plus 5. Okay, and then we take our x minus 3, come down, let's say the width of this box, and call it x minus 3. So to fill in each of these squares, what we're going to do is, let's say for this one, we look above and to the left and take the product. So for a product, again, you multiply numbers. 2 times 1 is 2. For powers of the same base, you keep the base, the x, and you add the exponents. And again, when there's nothing there, it's a 1. 1 and 1 makes an exponent of 2. Okay, for the next square, again, you look above to the 2x and to the left to the negative 3. 2 times negative 3 is negative 6, and we don't have anything to multiply that x by, so we just bring it along. Okay, next square. We look to the left, the x, and above, the 5. 5 times x, again, nothing to really multiply, just put them together. Okay, and last square, if we look up to the 5 and left to the negative 3, 5 times negative 3 is negative 15. Okay, so just like before when we used the distributive property, we ended up with two terms over here that could be combined because they were like terms. And that's how we ended up with a trinomial. So same idea over here. We still have like terms, right? And they still need to be combined. And just like when you use distributive property, those like terms will generally be right here in the middle, second and third term. When you use this box method, your like terms will be on a diagonal, right? So that first term, the 2x squared, has nothing to combine with. These terms on the diagonal, negative 6x plus 5x is negative 1x. And then that last term, negative 15, has nothing to combine with. And you'll notice we get the same answer no matter which method we use to multiply the two binomials.